Okay, so welcome back. So we're going to start adding a few more extra tricks and features to our synth. I've set up a simple sequence here. You can hear this sort of melody playing. Now, what might be quite interesting is to have a low frequency oscillator to start modulating some of these other parameters. So I will show you the next interesting stage. If you remember, I said that pure data has a distinction between the control signals, which are slower, and the audio signals, which are fast. They're optimized because they have to run at 44,000 times a second. Yeah, or so. Obviously, to generate this kind of quality of audio we need. So, but and for that reason, we can't feed the audio signals into, say, a number box, because number boxes can't update themselves that fast. We can't update the screen at that frequency. So, screens update at 30 or 60 or 120 frames a second, not 44,000 frames a second. So, but there is an object that lets us grab a high frequency audio signal and snapshot or sample it at a lower frequency and get get control frequency data back from audio frequency. So let's talk about that and then let's see what we can do with it. I'm going to start by putting down a toggle. If you remember the toggle that we used to switch on and off the metro for the sequencer, and we're going to use something similar here. We're going to add a metro to it. We're not concerned about the speed of the metro because this is really just the sampling frequency. So we'll say a metro 10, that's 100. It will tick every 100 milliseconds, so 10 times a second. And then we're going to send the output of that into this snapshot object. Now, snapshot object takes the metro and it takes an audio frequency signal, and every time the metro ticks, it outputs a control frequency signal. So let's just see that here. No, that's not what I wanted to do. I wanted to put a number there. So let's just move that up. Let's put a simple oscillator. We'll put a slider here. We'll call this LFO speed, and we will give it between about 0.01 and 1. 2, let's say. Apply that. So that's going to control another oscillator, simple sine wave oscillator, but we're now going to feed the output of that into the snapshot. And let's see what happens when we put that up and we turn the metro on. Now you're seeing we're getting, this is an audio frequency sine wave, 44,000 times a second, but it goes into the snapshot, and then every 10 times a second we're getting a quick sampling of that, which is the whatever the value of that is. And if we slow it down, then you'll see, let's slow it right down, and now you can really see that numbers decreasing, gets down to more or less -1 and then comes back up again, starts going up towards 1 and then comes down again, etc. So that's quite an interesting signal. What could we attach that to? Here's our melody again. Well, why don't we attach this to the ratio? So we're modulating the ratio now. And you see the ratio automatically moving down. Of course, when it gets down to the negative values, it's not very meaningful. So what actually is this ratio? Remember, this ratio box goes between 0 and 4. So here's a number between -1 and 1. How could we scale it to being between 0 and 4? Well, we can add 1 to it. So instead of being between -1 and 1, it's between 0 and 2. And then we can just multiply it by 2. And so now we have a number. If we looked at this number, we can see it's going down to 0 and then up again, 2, 3, almost to 4, and then back down again. So let's try putting this into our ratio. And we can now see the slider moving. When it gets down there, we start getting those really crazy sounds. Up this end doesn't make a lot of difference, but we could put the amplitude up a bit. And now we've created, with our low frequency oscillator up here, we've created some automatic modulation of this ratio. And of course we could put this speed up. We can make it really bounce backwards and forwards to be slightly less predictable, or like slightly less. Well, okay, so that's fun. So what we'll do now is we will take this up to here, and we'll take this up to here, bring this together. We don't really need these, but, well, actually, take that out. Let's just encapsulate that as what we will call the PD LFO, or my LFO. We can put that up here. And okay, we were controlling the ratio with it, so let's put these back in. We add 1 and we multiply by 2. Aha, we will have to go in there now and edit that, because what I didn't do is I didn't actually leave it connected to anything else. So let's hit this and put an outlet. It doesn't need to be an audio frequency outlet now, because we have, okay, we will now see we'll now see that we have an outlet here. And if we just put our number box back here again, put it back into our ratio, we should see that But of course, we can do a similar trick over here. So why don't we grab that component, copy it, paste it, and let's see this amplitude. What are the properties here? It's between 0 and 600. So here I will do the same thing again. I will add 1 to it, and then I will multiply it by 600, and I will feed that into the amplitude. And now you'll see okay, we don't need to multiply that by 600. In fact, that should just be by 300, shouldn't it? Because it was already between 0 and 2. So now you can see that we have 2 low frequency oscillators, and we're using one to modulate the ratio, one to modulate the amplitude at different speeds. Well, while we're about it, shall we do the same with the wave shaper? Why not? So, what is the wave shaper between? That's between 1 and 0, isn't it? So, in fact, this time I will simply divide it by 2. Feed that into the wave shaping. Put that on. So it's very easy to add more kinds of LFO, more kinds of modulation to various parameters here. So that's one way we could start expanding the synthesizer to make it do more interesting things. And we will return shortly with some more tricks. Okay, welcome back. I think we are coming to the end of this now. I've just rearranged this slightly, and I've been playing around with this quite nice riff for a few seconds. I'm going to give you a burst of. Let's put this ratio. Leaving the wave shaping constant. I've got the amplitude and the ratio on an LFO. I've just consolidated that stuff into the right there. And it's giving us a real sense of the different sounds that we can get out of this. Horrendous noises and some more sweeter sounds, I would argue, but some horrendous noises too. So. I think I'm going to make a longer recording of this, make it available for people to download. But I'm going to do the last thing we're going to add to this synthesizer. FL Studio now. Pure Data. Pure Data comes with a reverb. Not a great reverb, but one which can at least add another dimension of sound to this. It's called Freeverb. So let's put it in. The first thing to note is it needs a stereo input. Those are not stereo channels. Those are the wet and the dry side of the envelope. So let's just combine these together. We'll add an object which is simply adding nothing. It's just to combine the two. Pull that in here, pull that in here. I'm going to pull this whole section of volume over to the other side because we are get it out of the way, and I think I'm going to pull these, actually maybe I'll pull them up there, so yeah, that gets it out of the way, doesn't it? And so now we will add our Freeverb between the envelope stage and that takes a stereo input, between the envelope stage and the final volume. So just to hear how that sounds, you'll hear we've now added a bit of reverb to it. And you can see even when we stop the sequencing, because these are going on, I've got a lower envelope, these still got the sounds there. Take that off for a moment. So Freeverb can be controlled, is not controlled by sliders directly or the standard inputs. It's controlled by messages, rather like the V-line when we made the envelope generator. And Freeverb takes three messages. One is a wet value, and that has a slot obviously which contains that. One is the dry value, also has a slot, and the final one is room size. So a reverb obviously tries to emulate the echoes that take place in a room. They're not very distant echoes, so you don't hear the sound repeating, but you hear the sound kind of softening but filling out as well. So room size is pretty straightforward. If I pull the reverb over the Freeverb over there and pull these back a bit, the room size is, no, do it the other way around. It's pretty straightforward. We'll just make another slider, put it down here. We will call it room size, and it has a value between 0 and 1. And we take the output into the room size message, and the output from the message into the hot input of the Freeverb. So every time we change the room size, we update the value of this message, and that updates the value of the Freeverb. With the wet and dry, we would like to do the same thing that we did with the wet and dry values of the quantity of the envelope. So we will set this between 0 and 1 again, and we will call this reverb dry wet, just so it's intuitive to us. And so the output of this, we want it to be proportional to it. So when this is 0, we want 0 reverb, so the wetness should be 0. So that's pretty straightforward. We just take it out of that, go into and take the output of the wet message. Again, when we change this, we fill in the slot with the new wet value, update it, fire the message goes, updates the reverb. With the dry, we want to do the same as we did before. We want it to be the inverse of the wet signal. So in this case, we want to multiply it by -1, and then we want to add 1 to it. So here, if the reverb if this slider is at 0, we will multiply it by -1, so that will still be 0. We'll add 1 and it will become 1. If, on the other hand, it's up at 1, we multiply by -1 to become -1, and we add 1, 0. If it's 0.5, becomes -0.5, add 1, becomes plus 0.5. So it's doing the opposite of the wet signal. So let's now put those in, put the volume up, put our sequence back in, and now let's see what happens. Maybe the volume has to come down a bit now. So how does it, as we becomes wetter, we're hearing more and more of that and as we make the room size bigger, there should become more echo. So the room size becomes almost like a cathedral at this point. But we don't have to have all of it. We can still have... I'm not sure if you're able to hear over this. So the room size, as I said, becomes like a cathedral at this point. But if we have it wetter, there's more of it. We can take it back to being dry again. It's more or less gone at this point. With a very small room but a very high wet signal, you still get an effect, but it's more like being in a toilet cubicle. So I think this is it, guys. I think this is something I could use in a performance. I would certainly record some of this. I would certainly record some of this to sample, make textures, make loops, make other things that I can use in other pieces of music. I'm inspired, and well, in fact, I'm so inspired. Let me pull up Audacity at this point. I can make Audacity pull from the voice meter, and I think I even have Audacity set up to forward the output. Let's try and see. Yeah, it's responding. Like that. I may just put the volume up a bit. Well, I really want to play this now, and I'm going to go away and record it. And that's it. Thanks for watching this long tutorial, and please try per day to go out, try it, build something like this yourself, use it in your music. You'll be really happy. At least I am. So have fun, and Synths Media, I'm out. Thank you for watching.